Thanks for watching my video. Today we are going to integrate or secant hyperbolic of ax dx, right? So which is our answer is going to be 1 upon a tan inverse of sine hyperbolic of ax plus c. And this the integral of secant hyperbolic of ax can be expression 2, right? So one is 1 upon a tan inverse of sine hyperbolic of x and 2 upon a tan inverse of e to the ax, right? Such that we are going to take a is greater than 0. If a is equal to 0, then this will be divergent, right? So that means our integral does not converge, so that cannot be correct, right? So in order to prevent that, a must be greater than 0, right? So let's score our I to be our integral, then is secant hyperbolic of ax dx. Now substitution method, ax equal to u, let's put it, right? So if I differentiate it, a dx equal to du. Now putting here, or I is going to be integral of secant hyperbolic of in place of ax u, right? So and dx is going to be, if you find here, dx is du by a, right? Since a is constant, so coming out 1 upon a integral of secant hyperbolic of u du. And what, so which is equal to 1 upon a integral of secant hyperbolic of u is nothing but 1 upon cos hyperbolic of u du, right? And cos hyperbolic of u can be expressed as 1 upon a the integral of cos hyperbolic of u upon cos hyperbolic square u du, right? And now we know that from the identity, cos hyperbolic square x minus sine hyperbolic square x is going to be 1. Now if you find out here cos hyperbolic square x, then it is 1 plus sine hyperbolic square x, right? Now substitute here. So which is 1 upon a integral of cos hyperbolic of u 1 plus sine hyperbolic square u du, right? And now let's substitute again. Sine hyperbolic of u equal to d. If I differentiate, cos hyperbolic of u du equal to dt. You can watch all this in my previous video, okay? And since sine hyperbolic of u is t, so replace here 1 upon a integral of cos hyperbolic of u du is nothing but dt, right? So here substitute here dt upon 1 plus t square, and this is nothing but the inverse tangent, right? 1 upon a inverse tangent of t. Now 1 is t. Since this is t word, so we need the x, right? So we are going to substitute back. So I is going to be 1 upon a tan inverse of 1 is t. T is nothing but sine hyperbolic of u, right? Yeah. And u is nothing but ax, right? So if you find that 1 upon a tan inverse of sine hyperbolic of ax dx plus constant of integration. So which is our first result. Now for our second result, let's see. Now our I is going to be the integral, and substitution method same thing. Ax equal to y. Why I put here different things? So because that does not change the integral, right? So a, if I differentiate a dx equal to dy, so which is I is going to be integral of secant hyperbolic of y dy. In place of dx is dy upon a, right? Dy upon a. Since a is constant, 1 upon a secant integral of secant hyperbolic of y dy. And this is nothing but 1 upon cos hyperbolic of y, right? And if I use the definition of hyperbolic cosine of y, so which is cos hyperbolic of x is 1 upon 2 e to the x plus e to the negative x, right? Now use that, which is 1 upon a integral of 2 upon e to the y plus e to the negative y dy. So I hope this is clear. Now since 2 is constant, so taking out, right, which is 2 upon a integral of 1 upon e to the y plus e to the negative y dy. So which is 2 upon a. Now multiply both numerator and denominator by e to the y, this one, right? Now if you multiply, I is going to be 2 upon a e to the y upon e to the 2y plus e to the 0, right? E to the 0 is nothing but 1, right? Using the exponential law, which is 2 upon a the integration of okay, now substitute e to the y to be z, right? If I differentiate e to the y, dy is equal to dz. So which is 2 upon a integration of here and e to the y dy is nothing but dz, right? Dz, and e to the 2y is nothing but e to the y whole square, right? So e to the y is z side, which is z square plus 1. This is nothing but the inverse tangent of z, right? So which is 2 upon n tan inverse of 1 is z. Z is nothing but e to the y. So which is e to the y, and which is equal to 2 upon n tan inverse of e to the 1 is y. Y is nothing but ax, right? So which is ax plus the constant of integration. So then is the end of our integration for both of them, right? So therefore the integration of secant hyperbolic of x dx can be expressed in two ways, which is the first way is 1 upon a inverse tangent of sine hyperbolic of ax, and the second is 2 upon a tan inverse of e to the ax plus constant of integration. Okay, that is for our integration of secant hyperbolic of ax dx. So